Yeah.
Sorry, your phone won't be acceptable.
You ready? Here we go. 9.2, calculating power. There you go, a little too obvious sometimes. You're going to need a calculator. A phone won't be acceptable because I won't let you use it on tests. I'll put up with it just today. By Thursday, have a calculator, or you'll swap me your phone for a good calculator, because the phone calculators are finicky. Recall, from Ohm's law, we said this: V equals I times R. Last day. And what was I equal to? From your formula sheet. What was not equal to V times R. Now, ready, Mateo? Mathematically, what's happening between the letter I and the letter R? Adding, subtracting, multiplying, or dividing? So, how would I move the R over then? What's the opposite of multiplying by R? So that's why you could actually derive this. It's V over R, not V times R. But it's on your yellow formula sheet. And what was resistance equal to? V over I. I wrote down here, hey, you can also get these from your formula sheet. So let's start doing some examples. And I'm trying to make up reasonable numbers here. So an electric motor has a resistance of 12 ohms. It draws 8 amps of current. What's the minimum voltage required to run it? And I said, remember DFIC, data, formula, insert, crunch. So I always start out by saying, hey, what are they asking me to find? What are they asking me to find here? More specific in this question, what are they asking me to find? Voltage. So I always write down what they're asking me to find, and I write a question mark. Half the battle is figuring out what they want me to find. And now I'm going to list any other data that they gave me. I see a 12. See it? What's that 12? I see an 8. What's that 8? Amps is the units, but what is it? So what's my symbol for current? What's the equation that has a V and R and an I in it and has the V by itself, please? You can just say I times R and we'll figure it out, and that also reinforces what letters go with what abbreviations, right? So there's my formula. Now I insert the numbers. I is 8, R is 12. I tend to use brackets for multiplying when I handwrite, but you could write. The only reason we tend to shy away from that is in math, what does a time symbol also look like? An X, and that looks like algebra and things. So we tend to use brackets to separate stuff. Anyways, okay, what is 8 times 12? Get your calculators out. Not acceptable to just be passive here. What is 8 times 12?
96.
96? Anybody else? Is he right? 96 what? 96 what? Sorry? 96 what? Volts. Okay? So here's a follow-up question then. Here's a follow-up question. Mateo, with me. If a standard house outlet can supply 120 volts, could you run this motor from a standard house outlet? Yep. If we had gotten an answer of 150 volts, that would mean that if you plugged it in, your standard plug would not have enough energy to cause that motor to turn over. You'd need a special plug, a different plug. So one of the things I'm going to try and build in here, Lena, is teach you a little bit about how the power in your house, how the circuits in your house are set up. I think it's kind of interesting, and I'm a nerd. A blow dryer has a resistance of 13 ohms. Suppose you plug it into a 120 volt wall outlet. How many amps of current will it draw? What's this question asking me to find? And I think the resistance is 13. Current. I equals question mark? What have they told me? Aiden, what's that 13? Ohms, which is what? Resistance, yep. Keep going, Aiden. What's that 120? So I'm looking for an equation that has I, V, and R. Now this may sound kind of repetitive, but I'm going to be giving you another equation in a little bit, and so it's going to become a bit more of a things to choose from. But for now, I'm looking for an equation that's got I, V, and R and has the I by itself. I equals what? V over R, which is going to be 120 divided by 13. In your head, Mateo? This one not so easy in your head. 120 divided by 13. What do you get, folks? Give it to me to, let's say, 2 decimal places. 9.23 or 9.24? Did you round off properly? What comes after the... Okay. 9.23, 9.23 what? Amps. By the way, you'll notice I did the insert and the crunch all in one line. I'm good with that too. This is just a guide me try to say, if you're stuck, when in doubt, defic. In fact, in Physics 12 and Physics 11, I teach my kids 2 tricks. When in doubt, you defic, which is list your data, find a formula, insert and crunch, or you dolp, which stands for draw a little picture. And my kids all know if they come to a new question and they don't know what to do, dolp and defic. Sort of, yeah. I hate leaving a question blank. I find if I start to write something down, my anxiety goes way down and I do better. And so that's why I'm really big on, hey, when in doubt, write down what they're asking you to find. Because by writing something down, somehow your brain flows from your brain to your pen and you do better. I don't know why, but it works. However, I wrote here, most appliances don't tell you their voltage or their resistance or their current. In fact, you know what most appliances tell you? Their power. Measured in, anybody know what power is measured in? I'll give you a hint. Power is measured in what?
Watts.
Ah, there you go. That's my standard joke. Power is measured in what? Watts. Okay. Symbol for watts, capital W. If I'm being really fussy, Tristan, power is the rate at which electrical energy is transformed into other types of energy, usually heat. In fact, rule of thumb for any appliance, if any of you get into electricians or anything like that, the more heat an appliance moves around, the more power it uses, the higher its wattage will be. So I wrote down here, mix and match the following appliances with their power ratings. I've given you a bunch of appliances, and I've scrambled their power ratings over in the right-hand side. But we can, using our reasoning, figure out what some of these things are. You ready? Well, one of the things that I notice is an average light bulb. Has anybody put a light bulb in and noticed what the wattage is on an average light bulb? 150 is a very bright light bulb. Most of the bulbs in your house are 60-watt bulbs. So you know what? Let's put a 60-watt right there, and let's cross out that 60 watts. Looking at the remaining appliances, which ones move the most heat around?
Stove.
Okay, stove, is stove in there? Nope. Okay, and I'm going to give you a hint. This particular appliance moves so much heat around that it needs a special circuit and a special plug. A stove has a special plug. If you pull a stove away, you'll see the plug is not your standard plug-in. There's one more appliance in your house, yeah?
Microwave.
Nope. Microwaves plug into regular plugs.
Hot water.
Aiden, clothes dryer. Clothes dryer has an incredible wattage. It moves an incredible amount of heat around. So looking at the wattages that are left, what's the biggest wattage?
4,800 watts.
A clothes dryer, if you ever pull a clothes dryer away from the wall or a stove away from the wall, you'll see it's not plugged into a standard outlet. It's plugged into a 240 volt outlet. All your other standard plugs, all the plugs that you see coming out of my lab tables are 120 volts. Clothes dryer and stoves need a 240 volt, double the voltage, because they move they move a lot of heat around. Okay, what item has the next biggest amount of heat movement?
Kitchen.
Kitchen fan moves a lot. Really, kitchen fans get really, 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 really hot?
Microwave.
It says kitchen.
And what I'm asking, of what's left, what do you think has the next highest wattage? What do you think moves the most heat around? Hot water heater. Hot water heater takes around 3,000 or so watts. If we talk about microwave ovens, there's two types. There's the smaller kind, and there's the bigger kind. And that's really vague, I realize, Kiana, but you can tell by glancing at a microwave whether it's one of the smaller ones, whether it's one of the bigger ones. The bigger ones have a higher wattage. That's why, by the way, whenever you read the instructions for microwaving something, it says at the very, very end, times may what? Vary, because it doesn't know what type of a microwave you have. It doesn't know how many watts your microwave puts out. They come in two types. The bigger ones put out around 1,200 watts. Is that there somewhere? Except I didn't write it as, 1.2 kilowatts. Okay. Okay, from what's left, what gets the next hottest? What's left? Computer. So what do you think? How many watts does a computer usually pull?
800.
About 800. Of the two that are remaining, what uses very little power? What can run off of a small battery for a very, very long time? Clock. Clock gives off almost no heat. A clock requires about 0.1 watts. So what's a kitchen fan require?
150 or 150 watts.
So you need more than a light bulb to power a kitchen fan, because it does have an electric motor. And if you have your fan on, if you feel the housing, you will feel that the motor is getting a little bit warm. Do you need to know any of this? Mitra, I will not ask you questions like this, but I'm always big on trying to give you an idea of what a really big answer and what a really small answer is. So if you make a calculator mistake, you can glance at your answer and you can, wait a minute, Mr. Dueck just asked me to find the wattage of a toaster, and I'm getting in the thousands. This isn't a toaster, this is a hot water heater. I've made a mistake somewhere. Or Mr. Dueck asked me to find the wattage of a dryer, and I'm getting 80 watts about a light bulb. I've made a mistake somewhere. Turn the page. So, an appliance that has a higher rating, a higher power rating, uses more or less energy in 1 hour than an appliance with a lower power rating. What do you think? More. Power is how fast that object sucks up energy. Your clothes dryers suck up an awful lot of energy very fast, where the wall clock behind me uses almost barely any energy. It's a very efficient motor. It moves very slowly. That little battery will last a long time as an energy source, about a year as a matter of fact. Power is the rate at which energy is used up. As an equation, we say this: power is the amount of energy divided by time. Is that on your yellow formula sheet somewhere?
Yeah.
Okay. Where energy is measured in joules, named after a scientist whose last name was Joule. Symbol for joules, capital J. And time, the fundamental for time and unit for time in all seconds is not in all science is not hours, is not minutes. Time is always measured in. Which means if they give you a time in hours or minutes, you'll have to convert it. What are the units for power? Well, technically, it's a joule per second, but we've given that a name. We call it a watt. Power is measured in watt?
Watt.
Watts. Named after a scientist whose last name was?
Watt.
Watt. James Watt. By the way, this is the unit I have a science nerd beef with. James Watt really didn't do that much for science, but what he was a very good PR guy. And so he managed to get a unit named after him, even though he really didn't advance science much. I wish they would have named it after somebody else. In 1840, a scientist named James Joule, yes, that's where the unit joules come from, found out how to calculate electrical power. He found that power equals, Matteo, when there's two letters with nothing between them, what mathematical operation is between them? You answered this earlier. Really? That's divide?
Oh, no, sorry, multiple.
Times. Power equals V times I. This is called Jules Law. So it turns out watts is also volt amps, but I'm not going to freak out about that. This equation is called except if power equals V times I, we can also write Jules' law as follows. Since V equals I times R, I can write Jules' law like this. Instead of putting a V there, what's V the same as? What times what? IRI, although it's usually written like this, because I times I is I squared. Did I put that one on your yellow sheet or not?
Yeah.
I did? I would use that to find the power of an appliance if I didn't know the voltage, but I knew the current and I knew the resistance. I squared. What does squared mean? Times itself, times R. Oh, and also, I equals V over R, so you can also write it like this. That's also V times I. Although it's traditionally written as V squared over R, because instead of writing VV, it's easier to write V squared. Did I put that one on your yellow formula sheet? That's my way of saying, can you spot it? Is it there? Yes or no? Can I see? Okay. I didn't give you that one. Good. That one we don't use that often. So, Candace, last day I said if you know 2, you know 3, because if it's V and I and R. Actually, now that I've given you a formula for power, if you know 2, you know 4. If I give you any 2 of power, resistance, voltage, and current, we can find the other 2 in any circuit, in any appliance. Kind of like this. Here's our equations. Double check on your formula sheet. Can you find all of the above equations? Oh, I also took the power equation. I got the E by itself, and I got the T by itself. So let's apply this. Here's a circuit. It says find the current in your house wires if you plug in a 1400 watt hair dryer. I did some Googling online. I found some models of hair dryers, and I found their wattage. And one standard model has 1400 watts. Remember, I said DFIC. Okay. What's this question asking me to find? Current. Let's write down I equals question mark. What have they told me? Nice yawn. I'd yell, but I have no yell in me right now, so. Okay, good. What have they told me? Jordan, my angel, read the question. Find me numbers. We're on this example A. Find me numbers. Oh, 1,400. Okay, what's that 1,400? What are the units right next to it? Guys got to get with it. Okay? How did you figure that out, Rihanna? The units, watts. Power is measured in watts. This is why, by the way, I said last class, and I'll say it again, it's really worth memorizing what units go with what, because it cuts down on your thinking. This isn't enough. There must be something else. Oh, are there any numbers in the picture itself? Yeah? Oh. Does anybody know what the AC that I wrote there stands for? Nope. Not in electricity, not in circuitry. No, nice try. It stands for alternating current. What comes out of your plugs, there's two types of current, direct current and alternating current. We get alternating current, and I was being fussy. I wanted to do the diagram right. So, can you find for me an equation that has power and voltage and current in it and get the I by itself, please? You need to know where that is on your yellow formula sheet. If you don't have your yellow formula sheet out after I told you to get it out, you're foolish. What's the power? 1,400. What's the voltage? How many amps do we need to make this work? Go to your calculators. We're going to pause. I'm going to go 11.6 and I'll round off 7. I usually go to not more than 2 decimal places. Units. 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 Amps. Okay? I'm going to be asking you a bunch of these on your tests. We're going to practice them. Now, it turns out, and this might explain something to some of you if you've ever blown a breaker. A standard plug, a standard household outlet, can supply 15 amps of current, no more. So, how much does one hair dryer take? How many amps? Could you plug 2 hair dryers into this outlet? Nope, you'd blow the breaker. And this is what happens when you blow a breaker. What you've done is you've demanded more current than the system can safely give you. It could give you more, but it would heat up the wires and fire bad, so you trip a breaker. That's a safety feature that we built in. So what do you think would happen? So you have somewhere in your house, ask your parents if you don't know where it is, there's a breaker box, and it has a bunch of little black switches. If you tried plugging in 2 blow dryers here, you would hear a click. The room would go black, dark, because all the power would be shut off to that room, and any other parts of the house that were on the same circuit, so maybe the room upstairs or the room downstairs might also lose power. And then you'd have to go find the circuit box, reset the breaker, but you would not be able to plug, like if you then think, oh, I'll plug in the second blow dryer again, it's going to trip every time. Like it's not like, oh, somehow it'll work next time. It's a safety measure so that we don't burn houses down.
Can we try it?
Can you try it at home? Check with your folks. The only problem is if you blow a breaker and your dad's like on their computer doing typing and they lose everything, they're going to be a little perturbed, right? Or if they're PVRing something and that goes off, they're going to be a little perturbed. So it works, though. This is what happens if you ever blow a breaker. So in my house, for example, in my kitchen, I got one plug. I think, because I think the people upstairs must have something on that same circuit that draws a lot of current, maybe their TV or something, because I can't run a microwave from that one plug, even though that's the most convenient place for me to put my microwave. I blow the breaker every time. I learned that my first year living there. So my microwave is in an inconvenient place. But it's okay, it's a safety measure. Part C. If the hairdryer runs for 2 minutes, how many joules of energy will it use? If the hairdryer runs for 2 minutes, how many joules of energy will it use? All right. What's this asking me to find?
How many joules of energy?
And the symbol we're using for energy is a capital E for energy, question mark. What else have they told me? What's that 2? It's not power. It's not voltage. Time. Except I got a problem. I told you that time always had to be measured in what? Seconds. No, not watts. Time always had to be measured in seconds. So, help me out. How do I change 2 minutes to seconds?
That's 120 seconds.
I know it is, but how do you do that?
60 is the minute times 100.
60 times 60. Or
So I need you to do me a favor. On your formula sheet, can you find an equation that has the E by itself? Wait a minute, I didn't write power or did I write power anywhere in the previous question? Did they tell me the power? Oh, power was 1400? Because power is measured in watts. Okay. So how many joules of energy, if you run this hair dryer for 2 minutes, it's going to be 1400 times 120. It's going to be a big number. 168,000 joules. Or they might say this, 168 kilojoules, because kilo is 1,000. Joules get pretty big pretty fast. Now this may seem really, really obvious, but what if you ran it for longer? Would you use more energy or less energy? Okay, this is why Mitra, we tell you, shut stuff off if you're not using it. Okay? Which, again, you picked up on since you were like 6 years old or whatever. But here's the physics of it. The longer you run it, because energy is power times time, if that object is using power, and any electrical device does, then the more time, the more energy you're wasting. So shut stuff off. Turn lights off. Turn TVs off. Turn game systems off. Shut your computers off, because they use power, and they waste energy. So, ready, Mateo? Yeah. Quick like a bunny. Oops, I forgot to change the name here. By the way, down here where it says can you put Mateo's name there, please? On the next question.
Why Mateo? What's the difference between the Monte?
Because the example is Mateo, and I want to be consistent.
What's his name now?
Ready? And I spelled Mateo's name without a T, sorry.
yeah, what is?
I was typing in a hurry.
Wait, are we actually doing?
Ready? Read along with me. It says this. Okay? I want to give you examples of how this affects you. Hey, guys. Come on. Mateo has an extension cord plugged into a 120-volt wall outlet. Okay? He's planning a backyard barbecue, and he wants to run the following appliances. A 420-watt blender, a 1,200-watt outdoor projector, a 900-watt coffee maker, and a 660-watt stereo. I wrote down here, complete the following chart. The source voltage is 120 volts. So, blender, what was the power required according to this question? 420. What was the power required for the projector? 1200. What was the power required for the coffee maker? What was the power required for the stereo? Okay, what's the next column want? Oh, did they tell me the current in the question?
No.
Okay. I'm looking for an equation that has current by itself, and I guess I want it to have power and voltage. Because the voltage is always 120 volts.
I equals P over V.
Ah. We're not using the I equals V over R one. We're using the I equals P over V
Power.
because we know power and voltage. And I told you, if you tell me any two, I can find the other two. So you ready? On my calculator, how many amps are required to run a 420 watts a blender from a 120 volt? It's going to be 420 divided by 120, which is what? 3.5 amps?
3.5.
How many amps are required to run that projector?
2.
Do the math, please. Yeah, 2 is nonsense. Do the math, please. Guys, you can't guess. You have to calculate this.
10.
10. Right? 1200 divided by 120. How many amps are required to run the coffee maker? 7.5 amps. How many amps are required to run the stereo? 5.5 amps. Hey, what's the resistance in the appliance? Can you give me an equation that has resistance by itself, please? What's an equation that has R by itself? That guy only gave you one.
VI.
Sorry?
R equals
No, VI, no. You read it wrong. V over I. V over I. Okay. I know the voltage, it's 120. And I know the current in the first one. What's the resistance of the electric motor in the blender? 34.3 ohms. They're not going to work out nice. I can't make these work out nice.
Oh my, I got 34.
No, what's next to the 2? What's next to the 2? 34.3, kiddo. Or you could have said 34.29. Sorry, I'm coughing. What's the resistance in the projector? Well, that's going to be the voltage divided by the current. The projector has a 12 ohm resistance. Yep. What's the resistance in the coffee maker? 120 volts divided by 7.5. 16 ohms. What's the resistance in the stereo?
That would be
21.81. Okay. And I'd like you, so again, what I want to communicate to you, Casual, is if I give you any two, you can find all four. Okay, take a little hopscotching. But if I give you any two of power, current, resistance, or voltage, you can find the other two. If I know two, I know four. But here's the question. A standard household circuit can only handle 15 amps of current. Can Mateo run all of these appliances from one outlet? Hmm? Yes or no?
I don't think so.
Convince me.
yeah.
Because all of the lights will turn off. You have to
Too much energy.
So looking at what you have here, what appliances can he run successfully and still stay under the 15 amps of current?
You got the projector.
the blender.
Okay, he can run both the blender and the projector. Will that put him over?
No.
Okay. What else could he run? Coffee maker and stereo. That would work. Blender and can he run the blender, the coffee maker, and the stereo at the same time? Or will that put him over? In fact, you know what? As I look at this, I think I can say this. The blender and anything else, any one appliance can go with the blender. The blender can be with any other appliance. Otherwise, the coffee maker and the stereo. And I don't think you can run any other two appliances at any time, can you? You're going to blow a breaker. So if Matteo wants to do this, what he's going to need is a second extension cord, but he can't plug that second extension cord into the same plug. He's going to have to go to a completely different plug that's on a different part of the household circuit. Otherwise, he's going to blow a breaker. How many of you have ever blown a breaker before? Any of you? Okay, so now you know what you did. And that, by the way, that's a good thing. If that breaker hadn't blown, what you were really asking was, you were wanting to fit more current than the wire could fit through it without heating up. And we don't want wires to heat up because fire bad. Okay. A typical blender uses 300 watts. It's plugged into a 120 volt outlet. Find A, the current it draws, and B, the resistance of the blender. Try this on your own. I'm going to freeze the screen. You all have something to do math with, either your phone or a calculator. List your data, find a formula, insert, crunch, and let's see if we get the same thing when we're done.
So, do we like draw a line down the middle of A and B?
Sure, I did. There's a part A and a part B, so I drew a line, vertical line down the middle of the page. So I started out drawing a line down the middle of the page, and I kind of did list my data. I think the current you get is between 2 and 4 somewhere amps, so bigger than 2, less than 4. And I think the resistance you get is between 40 and 50 ohms somewhere, if you do it right. Yeah? Oh. Don't copy, but if you get stuck, you can look up. But this is what I ended up with, right? Get that okay? Did you get that okay? Okay. You're kind of zoning out on me, people. No copying.
Can I do the next one?
Pardon me?
Can I do the next one?
If you got that one right, you can certainly try the next one. What is the next one? Sure, and there's a part A and a part B. And a part C, apparently. You got it okay, Matteo? Yeah. Second one? Did you write down R equals question mark? Okay. The only equation that I could find was V over I. Well, I got the V in the question. Where'd I get that I from? Answer to part A. Yeah. So this is a 2-part question, and I have no problem giving you those. I feel it's fair, those are fair game, where you have to find something in order to find something in order to find something, okay? How many got both of these right? Like none of you, 2 of you, 3 of you, okay? Oh, still not done, okay? Don't just copy. A little warning, those of you that come here Thursday without a calculator, I'll be forcing you to trade your phone in for one of my calculators for the whole class. No, it'll be fair, because I've given you fair warning. If you want to try the next one, you can. I won't freeze the screen this time for the next one. But see if you can do it yourself. Clothes dryer is rated at 4,800. What do they want? Okay, you know what? I'm going to go like this. Here's part A. Here's part B. That's clever. You get that okay, Aiden?
Yeah.
Yep. So I got 192 volts, which is why, by the way, a dryer can't run from a standard outlet. It needs more voltage than a standard outlet. So that's why the answer to part C was nope.
What about I? Oh, wait.
Oh, for the I part, yeah, you know what? I did that right there. I did it on the same line each time.
I was confused.
Yeah. And then usually what I tend to do, once I get my final answer, I tend to put a box around it. Okay. Is that okay? Thumbs up? Let's keep going. I'm going to turn the page. So I Googled the stats for a PS4. A PS4 uses 140 watts of power. That's what it's rated at while playing games. How much energy is used when playing a game for 8 hours? Okay. What's this question asking me to find?
How much energy?
Energy, what letter are we using? What's our symbol we used for energy? Okay, capital E equals question mark. Mateo, what's that 140? It's not energy. Which is what? Power. P equals 140. What's that 8? What don't I like about that 8? Okay, it's hours. How do I go from hours to seconds? I don't know. What can I turn hours into? Oh, how do I go from hours to minutes?
Divide by 60.
Divide by 60, so 1 hour is 1/60th of a minute? Jordan. Just times it by 60. 8 hours is that many minutes. Now, how do I go from minutes to seconds?
Times it by 60.
Did I, on your yellow formula sheet, give you a shortcut to go from hours to seconds somewhere?
Yeah, you think? An hour equals 60 minutes equals 3,000.
There's where the 3,006, if you want a shortcut to go straight to seconds, it's times by 3,600. It's times by 60 times by 60. So, what is 8 times 60 times 60?
Let's find it.
I get 28,800 seconds.
Yeah,
All right,
8,800.
me too. I'm looking for an equation that has an E by itself and preferably a P and a T in it. What is it? Times? That's what we're going to do? Okay. So it's going to be, what'd you say, what's power, what's P in this question? What's T in this question? Not 8. What's T in this question? Yeah, more specific. 28,000, okay. There's the insert part. How many joules of energy will you use playing this video game for 8 hours? And this is one of the reasons I want you to get a scientific calculator, because your phone calculators might not handle this number. I get 4032 and 3 zeros. Yeah?
Oh, 3,000.
4,032,000 joules of energy. What that means, Candace, is it turns out 1 joule is actually really, really, really small. On your parents' electric bill, they are charged not in joules, they are charged in what are called kilowatt hours. By the way, look up. Can you see power times time? That is energy, because kilowatt is another way to remember. Watt is power, hours is time, not the units we like. But that gives them numbers that aren't so big, because if your parents were getting charged 75 billion joules a month, they'd freak out, but they also wouldn't understand it very well. We don't deal with really, really big numbers all that well. And so the standard unit of energy measurement on a bill is the kilowatt hour. From your formula sheet, what's 1 kilowatt hour the same as? Find it, please. Not yet. I think I gave you a number. Didn't I? 1 kilowatt hour equals what? Can I steal your yellow sheet, please?
Yeah,
You can put your phone away.
3,600.
Yeah, there's a number on there, right?
3,000,000.
Okay, this is what I'm looking for. 3, what is it?
3,600,000.
This is our conversion factor. So, going back to the previous example, how many kilowatt hours were used by the PS4? Well, no, that's how many joules. How do I change that into kilowatt hours? It's going to be something to do with this number. Kilowatt hours is going to be joules divided by 3,600,000. If you want to go in the other direction, if you want to go from kilowatt hours back to joules, it's times, because the opposite of dividing by that, timesing by that. So it's going to be an hour answer, 4032000. How many kilowatt hours? How many kilowatt hours? Yep. 1.12 kilowatt hour. K, capital W, lowercase h is the abbreviation for kilowatt hours. How much would it cost? Well, it turns out on your electric bill, they charge you per kilowatt hour. Right now, BC Hydro is charging around 7 cents per kilowatt hour. So how much does it cost to play the game for 8 hours? Well, what if I included that somewhere on your formula sheet as well? Did I include some way to find cost? Yeah, how? What? Cost equals the kilowatt hours times the rate. So how many kilowatt hours was this game using playing for 8 hours? How many kilowatt hours? Farine, 1.12 times 0.07. How much does it cost to play the game for 8 hours? About 8 cents. And this is part of the problem. We have become, Brendan, so good at creating electricity on the cheap that we're not motivated financially to shut stuff off. But wait a minute, Mr. Dueck, Lena says. You told us don't waste energy. Absolutely. Because even though we create the energy for very, very cheap, very, very inexpensively, we're still doing damage in creating it in terms of climate change and greenhouse gases. That's why you shut off the lights. Not because it's going to cost you lots of money. Here in BC, we have cheap power. We shut off the lights because here in the world, we can do better. How many more am I going to get through here? Multi-steps, and then I have homework. Okay, so we are going to, what have I got, 8 minutes left? Give me a second. There's about 7 minutes left. I didn't quite finish the lesson, but in terms of the homework, I think certainly you can do this front page. There's enough, guys, there's enough room here to list your data, find a formula, insert, and crunch. Okay? Page 2 is energy calculations. I really haven't done as much practice with that as I like. You may feel comfortable, but they're talking about kilowatt hours and stuff here, and I want to do more examples. But certainly I think the first page you can get done. And then next class we'll finish off, we'll assign more, and also there's going to be some homework from the notes as well. Eventually I'll also be assigning all these lovely questions here, analyzing circuits and stuff.